Here's a question that sounds simple until you actually think about it. How do you hide in the ocean? On land, the answer is fairly intuitive. Match your background. Stay still. Use color, pattern, texture. A stick insect looks like a stick. A snow leopard looks like a snowfield. You blend in, and if you do it well enough, something that wants to eat you looks right at you and sees nothing. The ocean should work the same way. Except it doesn't. Because the ocean isn't one environment, it's several completely different ones stacked on top of each other, each with its own rules, its own light conditions. Near the surface, there's plenty of light. Go deeper, and the light starts to change, shifting, dimming, compressing into a narrow blue band before disappearing entirely. By the time you reach the bottom, you're in a world of total darkness, where the only light that exists is light that living things make themselves. Every 100 meters you descend, the rules of camouflage change. The strategies that work brilliantly near the surface become useless, deeper down. And the solutions evolution has found at each level are so strange, so specific, and so occasionally absurd that they raise one question worth following all the way to the bottom. Does perfect camouflage actually exist? Or does every solution just create a new problem? If that question interests you, make sure you're subscribed, because what we're about to find is stranger than anything you'd expect. Let's go. The sunlight zone runs from the surface down to about 200 meters. It's the most productive part of the ocean, warm, well lit, full of food, and absolutely crawling with things trying to eat each other. If there's a neighborhood in the ocean with a serious predator problem, this is it. The camouflage challenge here is a strange one. Light comes from above, hits the water at all angles, and scatters everywhere. There's no single background to match, no convenient rock to press yourself against. You are essentially floating in an illuminated blue void, visible from above, from below, and from every side simultaneously. Evolution's first answer to this problem is one of the most elegant solutions in all of biology. Just become see-through. The moon jelly does this almost perfectly. Its body is roughly 95% water, and the remaining tissue is arranged in such thin, translucent layers that light passes straight through it. There's almost nothing there to cast a shadow, reflect a surface, or create a silhouette. A predator looking at a moon jelly from any angle is essentially looking at whatever is behind the moon jelly. The jelly has opted out of the entire question of what color to be by simply not having a visible surface at all. It sounds like a perfect solution, and it mostly is, with one catch. Organs are not transparent. The moon jelly still has a digestive system, reproductive tissue, a network of internal structures that can't be made see-through without also making them non-functional. So if you look closely enough at a moon jelly, you can see a faint four-leaf clover shape at its center, the one part of it that light can't pass through. Perfect camouflage, with a small asterisk. A different solution comes from the sardines, and it is in its own way just as clever. Rather than becoming invisible, sardines become mirrors. Their scales are packed with tiny crystalline structures called platelets that reflect light in all directions. The effect is that a sardine doesn't look like a fish. It looks like a fragment of the water's surface, flashing and scattering light the same way the ocean itself does. In a school of thousands moving in perfect synchrony, the visual effect to a predator is less, "Here are some fish," and more, "Here is a confusing, shimmering disturbance that I cannot resolve into anything edible." Transparency and reflection. Two completely different strategies, both working with the same raw material, the light that's available. But as we go deeper, that light starts to run out, and both strategies start to fail. Below 200 meters, something shifts. Sunlight still penetrates this far, but it's changed. The reds, yellows, and greens have been filtered out by the water above. What's left is a narrow band of deep blue, dim, directionless. This is the Twilight Zone, and it creates a very specific camouflage problem that neither transparency nor mirroring can solve. The issue is silhouettes. Even in this dim blue light, a predator looking upward can still see, because anything between them and the faint glow above will appear as a dark shape against a lighter background. You could be perfectly transparent, perfectly mirrored, completely colorless, and you'd still cast a shadow visible from below. In the Twilight Zone, your own silhouette betrays you. Enter the hatchetfish, and one of the most counterintuitive camouflage strategies ever evolved. The hatchetfish solves the silhouette problem by producing its own light. Along its underside, it has rows of specialized light-producing organs called photophores that emit a soft, downward glow, carefully calibrated to match the exact intensity and color of the faint light filtering from above. The result? When a predator looks up at a hatchetfish from below, instead of seeing a dark shape against a lighter background, they see nothing. Or rather, they see what appears to be a continuous, unbroken patch of open water. The hatchetfish has erased its own outline by filling it in with light. This strategy is called Counter-Illumination, and it is the kind of solution that, once you understand it, seems almost too clever. The hatchetfish isn't hiding from light. It's using light to hide. It has weaponized the very thing that was exposing it. The sophistication goes further. Its photophores aren't fixed. They can adjust their output as ambient light changes, getting brighter as the fish ascends into lighter water, dimmer as it descends. It does this automatically, all the time, without thinking about it. Which leaves one question hanging in the dark. If counter-illumination is this good, what happens when the light disappears entirely? The answer will surprise you. Below 1,000 meters, the sunlight is gone. Completely. The only light that exists in the midnight zone is bioluminescence, light produced by living things, for their own purposes, in an otherwise absolute darkness. In this environment, the rules flip entirely. There's nothing to be transparent against. There's no background to mirror. Silhouettes don't exist because there's no ambient light to cast them. The threat isn't being seen in the light, it's being seen by someone else's light. And the most dangerous light of all belongs to the deep-sea anglerfish. The deep-sea anglerfish is one of the more architecturally unsettling fish in existence. It has a bioluminescent lure, a modified spine dangling in front of its face like a fishing rod that produces a soft, pulsing glow in the darkness. Small fish and crustaceans, drawn to any point of light in the void, swim toward it. The anglerfish waits. The anglerfish has enormous teeth. You can see where this is going. But here's what's easy to miss about the anglerfish. The lure isn't just an offensive weapon, it's also part of a camouflage system. The anglerfish's body is coated in skin that absorbs up to 99.5% of incoming light, making it one of the darkest biological surfaces ever measured. This ultra-black coating means that when the lure glows, only the lure is visible. The fish attached to it is essentially invisible. Prey swim toward a mysterious floating light, and the mouth they're swimming into doesn't exist, visually, until it's too late. Ultra-black skin works by a specific microscopic structure. The melanin granules in the skin cells are arranged in a way that scatters incoming light into adjacent cells rather than reflecting it back. Each photon that hits the surface gets bounced deeper into the tissue until it's fully absorbed. The result isn't just dark, It's the absence of surface. A creature coated in ultra black doesn't look black in the way a dark object looks black. It looks like a hole in the water. It is, in a sense, the logical endpoint of the camouflage journey so far. Each strategy is a response to the specific light environment of its layer, and each one is, within its layer, almost perfect. Deeper still, past 3,000 meters into the abyss, something unexpected happens. A few animals down here are red, not dark red, bright red, vivid, saturated. The kind of color that seems designed to be seen rather than to hide. At first glance, this looks like a mistake or a display, but it is in fact one of the most elegant camouflage tricks in the ocean. Here's the physics. In the abyss, the only light available is bioluminescence. And almost all bioluminescence in the deep ocean is blue. Blue light at these depths is the only light that exists. And here's the crucial part. Red absorbs blue light completely. A red object, illuminated only by blue light, reflects nothing back. It appears to any eye adapted to these conditions as pure black. The bloodbelly comb jelly is a perfect example. Near the surface, photographed in white light, it appears rich, deep crimson, beautiful, conspicuous, completely visible. But in the abyss, under the only illumination that exists, it is functionally invisible. It has hidden itself using a color that looks, in any other context, like exactly the wrong choice. Red camouflage is perhaps the most counterintuitive strategy in this entire descent. It only works because of a very specific set of conditions. Conditions that happen to be permanent and universal at abyssal depths. In any other environment, it would be a disaster. Here, it's perfect. So we've now descended through 4 layers, and at each level, evolution has produced a different answer to the same question. Every solution is tailored precisely to its environment. Every solution is, within that environment, nearly unbeatable. And yet none of them are truly perfect. Every single one breaks down the moment conditions change, which means the real question isn't which strategy works best at a given depth. It's whether there's a form of camouflage that doesn't depend on depth at all. As it turns out, there is. And it doesn't rely on darkness or distance to disappear. It lives in the bright, busy shallows of the Indo-Pacific, where predators are sharp-eyed and the stage is always lit. The mimic octopus was first documented in 1998 off Sulawesi, Indonesia, and it has no fixed disguise. It doesn't match one background or commit to one species. Instead, it actively transforms, changing color, reshaping its arms, altering its posture to impersonate other animals entirely. Lionfish, flatfish, banded sea snakes. And each impersonation is behavioral, not just visual. It doesn't just look like a sea snake, it arranges its arms in the characteristic banded pattern and moves with the sinuous side-to-side motion of a snake pushing through open water. It's not wearing a costume, it's giving a full performance. When threatened by damselfish, it has been observed selecting the sea snake disguise specifically, because sea snakes eat damselfish. It isn't just hiding, it's choosing the most threatening identity available based on who's causing the problem. It doesn't disappear. It becomes something that has no reason to hide, because everything around it has a reason to stay away. We started at the surface with a simple question: how do you hide in the ocean? The descent gave us 5 completely different answers, each one nearly unbeatable within its layer, each one quietly revealing a new weakness the moment conditions changed. Transparency works until you have organs. Mirroring works until the light angle shifts. Counter-Illumination works until the light disappears. Ultra-black works until something gets close enough to touch you. red works, until you leave the abyss. Only the mimic octopus sidesteps this entirely, reading the situation, selecting the response, turning camouflage from a fixed feature into a skill. Camouflage isn't about hiding. It never really was. It's about controlling what others are allowed to see. And in the deepest, strangest corners of the ocean, the most powerful form of invisibility turns out to be this. Don't hide at all. Just become something else entirely. So what do you think about all of this? If the mimic octopus just bent your sense of reality, don't look away yet. Subscribe to the channel and keep the journey going. Then dive into our full video on octopuses, where you'll uncover how these masters of disguise think, adapt, and transform their bodies into living, breathing illusions. See you in the next one.